All right, let's just jump right in. Generative AI. I mean, it feels like a genuine superpower for software developers, right? You can create code at these unbelievable speeds. But the big question is, how do we take this incredible new tool and actually use it like professionals? To build the reliable, critical systems that we all depend on every day. So first, let's start with a term you're going to be hearing a lot more of, vibe coding. This is pretty much what it sounds like. It's when a developer gets an idea, they throw a prompt at an AI, they get some code back, and then they just kind of poke at it and tweak it until it feels right. It's super fast, it's really intuitive, and believe me, it is happening all over the place. And look, this sounds amazing, doesn't it? For whipping up a quick prototype or maybe a personal project, it's an absolute game changer. But what happens when you start building mission-critical systems this way? What happens when your banking app or your hospital software or even the power grid is built on a vibe? And that right there brings us to the absolute core of the issue. Building software on intuition alone is risky enough, but it gets way more dangerous when that intuition is guiding a machine that doesn't actually understand a single thing it's building. Because while vibe coding feels super productive in the moment, it's quietly introducing these massive long-term risks into our systems. The architecture starts to crumble, brand new security holes just appear out of nowhere, and you start piling up this invisible debt that's almost impossible to see until, well, it's way too late. And this debt, it's a totally new and, frankly, a much more dangerous kind of technical debt. We're not just talking about messy code anymore. We're talking about a fundamental gap in our own understanding and control over the very systems we're creating. Here's the basic problem. It's all about a mismatch in speed. An AI can spit out thousands of lines of code in just a few seconds, but it can take a human engineer hours, sometimes days, to actually read, understand, and then validate that all of that code is correct, that it's secure, and that it actually does what it's supposed to do. This is what we call the verification gap. And this just perfectly illustrates the entire economic shift that's happening in software engineering. For decades, the slowest part, the real bottleneck, was a human physically typing out code. Now, that's instant. The hardest part, the new bottleneck, is proving that the mountain of code the AI just handed you is actually right. So if vibe coding is the problem and it leads to this really dangerous verification gap, what's the solution? How do we use all this incredible power without inheriting all of the risk? Amazon CTO Werner Vogels, he absolutely hit the nail on the head with this. The entire focus has to shift away from the code itself, that's the output, and move to the instructions we give the AI in the first place, the input. And that brings us to the hero of our story today, spec-driven AI development. The idea is, instead of a vague vibe, you create a detailed, formal, human-written specification that acts like a contract. It tells the AI exactly what to build, how it needs to be built, and all the rules and constraints it has to follow. The analogy here is just perfect. You would never let a construction crew start building a skyscraper based on a rough sketch and a vibe. No way. You give them a detailed, precise architect's blueprint. In this new world of software, the specification is that blueprint, and the AI is the incredibly powerful, incredibly fast construction crew. Okay, so what does one of these software blueprints actually look like? Well, it's not just a single document. It's really more of a layered stack of instructions that translates a big, high-level idea all the way down into a concrete technical reality. It all kicks off at the very top with business intent. I mean, what are we actually trying to do here and why? That big why then gets translated down into a functional spec, which describes exactly how the system needs to behave. From there, we design the architecture, the structural blueprint. And then we get to these really critical technical layers. API contracts that set the hard rules for communication, and finally, test specs that give us a concrete way to prove the whole thing is correct. See how each layer adds detail and gets rid of any guesswork? And what's so cool about this slide is you can see just how concrete this gets. This isn't some vague description. An API contract like this is a rigid, machine-readable set of rules. It tells the AI, hey, when you get a request, this is exactly what the data will look like, and this is exactly what the data you send back has to look like. There's absolutely no room for vibes here. Okay, so if we're writing all these detailed specs and the AI is writing a bunch of the code, the obvious question is, what's left for the software engineer to do? What does this mean for their job? And this is maybe the most important part of this whole story. This is not about eliminating engineers. It's about an evolution of the role. The value of a great engineer is shifting upward, from being a master of programming syntax to being a master of entire systems. This change is ushering in the era of what some people are calling the Renaissance developer. This person isn't just a coder anymore. They're a multidisciplinary systems thinker, they're a technical writer, and they're an architect, all rolled into one. I mean, just look at this comparison. The core skill shifts from knowing a programming language inside and out to truly understanding how complex systems fit together. The whole workflow moves from reactively fixing bugs and coding on a vibe to proactively designing resilient systems from the start. Your value is no longer just shipping features, it's providing that crucial architectural oversight that guarantees the AI builds the right thing the right way. So here's the bottom line. The goal here is not to automate coding out of existence. The goal is to elevate the entire field of engineering. We're using AI as a powerful tool to automate the most repetitive, tedious parts of the job, which frees up these brilliant human minds to focus on the truly hard problems: design, architecture, long-term strategy, and making sure the systems we build are safe, secure, and reliable. And that really leaves us with one final and I think a pretty important question for all of us to think about. As AI builds more and more of our digital world, we really have to ask ourselves, is the software we rely on every single day being built on a solid, well-thought-out blueprint? Or is it just being built on a vibe?